In this case, first we'll start with the concept of straight line. So the known formulas we know, y equals mx plus b is known as slope intercept form, where slope is m and b is the y-intercept. When you are taking y equals y naught plus m of x minus x naught, this equation is known as point slope form. So this is the equation of a straight line when the slope m is known and a given point on the equation like x naught, y naught is also given. And then we have another standard form like ax plus by equals c. So these are all linear forms and represents the equation of straight lines. The second one, we are going with x squared plus y squared equals a squared. This is the equation of a circle center at 0, 0, and the radius is a. So this can be written as also x squared over a squared plus y squared over a squared equals 1. As you see, if you divide each term by a squared, you can form this one. And we are keeping this one for purpose. You will see in the next one when we talk about ellipse or oval. This can be written as also for the circle x minus h squared plus y minus k squared equals a squared. So the difference between the first one and the last one on circle, they have the same area and the perimeter, but center is shifted from 0, 0 to hk. Now coming to number 3, ellipse or oval. Now we are having a and b, they're different. When a and b are equal, then again it will be a circle. So the properties will be very similar. For example, when I'm taking area of a circle, for example, you have a circle like this here, and the radius, say a, so then area will be pi a squared. And the total arc or the perimeter or circumference will be 2 pi r. So the ideas of those could be think like this, pi a times a for a squared. This one is pi times a plus a. So we'll be using that idea for number 3 when I have oval like this. In this case, this length is called semi-major axis length is a, and that one is b, as you see from the equation. In this case, when I'm looking for the area of the oval, then it will be pi a times b, because we have a, they are equal here, but for the oval, they're different. When I'm looking for the total circumference, this will be again pi times a plus b. Here we have written a plus a. So these are the connections. So next we are going to parabola. When you have y equals x squared, so y equals x squared will be like this as a parabola. The axis will be the y-axis. If I write this one like x equals y squared, so then it will go like this. All right. And then when you go to y equals y naught plus a of x minus x naught squared, so what happens in this case, this one is very similar to the first one, only the vertex will shift somewhere. We call it x naught, y naught. So this is the parabola here. And the same way, the other one also you can consider. The vertex will be shifted somewhere, depends on your x naught, y naught values. And then the graph will go like this. And the last one, we have the hyperbola. When I'm taking x squared minus y squared equals any constant, then, and in this case we say that a is a positive constant, then when y is 0, x will be plus or minus square root of a. So then you can put here and here. Graph will look like this. But when I'm taking the next one, like I have y squared minus x squared. In this case, I need to say x is 0, then y will be plus or minus square root of a. So then it goes here. And then the graph will go like this. Like this. This is the rough idea. So in my next video, then you will see the application of all of this. Thank you for your attention.